continue from our previous video. In the last lecture, when we talk about the linear regression at the end, we use the standard unit to find the regression line. If your numeric attribute both are in the standard unit, the linear regression will without the intercept. So the estimate y in standard unit will equal to the correlation times the x in the standard unit. So at the end of the last video, we talked about if we want to have the x and y attribute are in the original unit, so we still can find our regression line. But on the other hand, we will have the slope and intercept. So then we get the result for the y equal to mx plus b. So the slope in the original unit will be the correlation times the standard unit. Correlation times the standard deviation of y divided by the standard deviation of x. And also the intercept will be the average of y minus slope times the average of x. So in this video, we will go back to see the family height. That's what I quickly show you in the previous lecture. So we will review that again. But before that, I just want to mention earlier, actually, when I write the slope function, so here actually is the typo, because like you see earlier, the slope will be the correlation times the standard deviation of y divided by the standard deviation of x. So please make sure we will correct this one. So then you will find out if we do that. So you will see, so that's why earlier, the previous video, the result will be slightly different. So when you have your correlation coefficient value, then we really calculate the slope as well from what we have. Then you will see the slope not exactly equal to the R, correlation coefficient, but they are very close. Okay, so that's why the same thing we can see if we change to the 0.75. Right, so you see they are, at least the first two digits, they are exactly the same. Even you put that as a negative. Okay, so you see when they run up, they are still negative 0.75. Okay, so just one correction from that. So after this correction, we back to see our family height example. So remember, when we have our family height, we have our parents, the father height and the father height and the mom height, and also the adult children's height. And also from our technique we used from the previous lecture, we use the nearest neighbor to find the predict children height. So that's why here we have the parents' height. We average father and the mom's height. Then we have the children height here. According to our nearest neighbor prediction, we will have a nearby x to find the average of the y. So in this example, we do the same thing before. We're using within plus minus ½ inch. For example, if the parent's average height is 68, so we have the nearby is within plus minus ½ inch. So that's why we have our prediction height function. So in here, actually, we pass the parent's height. So then we find in that range all the children's height, then we find the average. Okay, so that's our function. With this function, we calculate according to all the average height for the parents. So then we find the corresponding average children height. This one is we call average neighbor prediction. That's we use the nearest neighbor prediction. So then we can have our children's height to calculate. So you can see they take a little while. So then besides we have the average parent's height, the original children height. So then here is the average neighbor prediction. since now, that's the one way we can do the prediction. Okay, but also now we also want to use our slope, intercept the regression line we get. So since earlier we know the slope is the correlation times the standard deviation y divided by standard deviation x. So that's why we pass our table and the x and the y, so that we can find the slope. And also the same thing, we can find the intercept. So now you can see the slope is about 0.63. So that means every 1 inch higher for the parent's height, the children average height will be 0.63 more. And the intercept is about 22.6. Of course, after we get this line, we can plug in the original parent's average, so times the slope plus the intercept. So we can get another column. This column is still the children prediction, but we use the regression. Okay, so after we add this column in, yeah, so you can see, yeah, they are pretty close according to the nearest neighbor prediction and the regression prediction. Okay, so then we can also put them in the scatter plot. Okay, so you can see here, the light blue line is our regression line. So the yellow one, the dot, is our nearest neighbor prediction. They kind of very close by. So the only thing different is when we're using the nearest neighbor technique, from earlier when we run, you can see they take a little while because according to our data set, remember each pair of data, they need to find in that range all the children, all the y value, we find the mean. So that's why actually according to we have almost 930 row. In each row in the nearest neighbor technique, we need to find the average again in that region. But when we use the regression prediction line, we just need to plug in the x is the average parent's height. So then we times the slope plus intercept. So we got the prediction. So the result is pretty close. But one thing is just the run time will be slightly different from these two techniques. Okay, so that's kind of to more clearly to explain from at the end of last lecture how we get this regression line. So how we can know the slope and intercept, how to calculate that. Okay, so that's our regression, the regression line equation in the original unit. Okay, so that's our demonstration. So continue, we will work on 2 discussion questions. Okay, so the first one, this discussion question. So please make sure after you understand the question, you will pause the video and work by yourself before you see the answer. So in this question, we will have a course. So this course, we have 2 data. We have the midterm exam data and the final exam data. In the midterm exam, the average is 70. Standard deviation is 10. And in the final exam, the average is 50. So much lower. So you can see the final exam maybe is much harder. So the standard deviation is 12. Then we also put these 2 data in the scatter plot. Okay, so compare the midterm exam and final exam scored. We get the correlation is 0.75. So now, since you have 2 numeric attributes, we know their average and the standard deviation, and we also know the correlation. So how you use one of the numeric data to predict the other one. So here, if one student score in the midterm is 90, what the final exam you will predict? And also, how about 60? Okay, So before you see the answer, please pause the video. Give yourself 2 minutes to see how you will get the answer. And also, you can work with your peer if you need more time. Okay, so I assume you already paused the video and work for 2 minutes, right? So how should we find the prediction? We have the midterm exam 90, how we predict the final exam. So you see here, since we know the average and standard deviation for both numeric attribute, and we have their correlation, right? So that's why we should go back to see our beginning about our linear regression line, right? So our estimate y in standard unit will equal to the r is the correlation times the x in standard unit. Okay, so of course, this x and y is the standard unit. So since we know the standard deviation and average, so of course we can plug in to get the standard unit for our x. So this x is, we just say this x is our midterm exam. So by giving our midterm exam is 90 minus the average of the midterm exam, divide by standard unit, standard deviation of the midterm exam, times our correlation, we can get the estimate final exam, but in standard unit. Okay, so that's how we can do that. So those 90% midterm exam, average of the midterm exam, standard unit of the midterm exam, and the correlation, that's all known value, so we can plug in. So after we plug in, we get is the y in the standard unit. However, what we need is we want the estimate of the y in original unit. So that's why we can plug in the value we know. Since we know the average of y, we know the standard deviation of the y, so we can plug in to get the estimate of y. Okay, so that's how we get the answer. So of course, we can write in our Jupyter notebook. So here is our known value. So we just make the midterm exam, we say that's x. So the final exam is y. So we have the standard unit and the average for the midterm exam, and the standard unit of the final exam and the average. So we have the correlation. So like earlier we say, since we know the final exam in standard unit equal to the correlation times the midterm exam standard unit, so then we just plug in. Okay, so after we get the y final exam in standard unit, we just need to plug into here, since we have the average of the final exam and standard deviation of the final exam. So that's why we know when the midterm exam is 90, so the final exam will be 68. So the same thing, the second question, midterm exam is 60, then our final exam is 41. Okay, so that's our first discussion question. Please make sure you will work on that in your Jupyter notebook. Okay, so that's our first discussion question. About the second discussion question, I will skip here because the next page, actually, I do provide you the answer. So this one, since that's discussion question, I do want you to discuss with your peer group to make sure you got the answer for this, you understand the answer for this discussion question. So then I will just skip here. So I will let you guys work on that. So in the last minute for this video and the next video, let's talk about our topic for the lecture 31. Let's talk about the least squares. Before we talk about the definition, then let's go to the demo example. Okay, so in this demo, we will show you the error in estimation. So in this example, we have another data set. So this data set actually is the presidential election result in 2016. Okay, so from here, after we read data, you will see that's the information about the state and each district, the voting district. So their median income and the percentage voting for Clinton and how many percent they are above college. So from this table, we only focus on two attributes. We want to see their relationship. So we have the median income and the college percentage. So that's why we drop the rest of that. We only have the median income and the college percentage. We don't know how's their relationship. So of course, the first thing, that's the scatter plot. So what did you see from the scatter plot? Okay, right. So we do see they have positive association, right? So the next one, of course, we want to find the correlation. Before we see the correlation, how about you guess what the value for the correlation? Then we will see in the next video.